Okay, so basically I'm going to tell you about what's new in Driverless AI. And Driverless AI, our pretty well-known tool for automatic machine learning. It's actually, so on this today talk, I'm going to speak about highlighted topics basically, right? So I'm going to tell you about what we have in Driverless AI and what it has to do with a low-code tool, open source tool we have actually at H2O. Well, first of all, machine learning for the last 50 or so years actually did a long way, went a long way from quite simple models to quite complex one, right? And it's basically been led not just by the revolution in the algorithms in themselves, but also thanks to the data we have on hands, right? People actually able to store more data. So, for example, the very first algorithms in machine learning we have was, let's say, k-nearest neighbors, which was a very good approach for small data sets, not just small in size, but also small in the number of columns you actually can, use, because as soon as you have more columns, KNN kind of tends to break. So after that, like additional research and more requirements from a business and and from real life, algorithms starts to evolve to complex ones. Like we had decision trees, and decision trees actually, they can handle some non-linearities in your data set. We're also trying to mimic, human way to think about problems, like if else, then what. So after that, we, switching gears, we go to the neural net revolution. We also have different algorithms in like a gradient boosting machines, random forest, which actually able to handle tabular data, which has a different, nature of the columns fairly well compared even to deep learning, for example. And later down the road, H2O come to place. And H2O as a company started from a promise of building fast, scalable, reliable algorithms, like you saw in the previous presentations, like about H2O open source. So it was all about, hey, let's allow business users, allow users actually not care about the scalability and how to handle huge amount of data. Just give us the data and the cluster will take care of you. So immediately we recognize a problem that the algorithms being offered. But what about hyperparameters tuning, right? We need to tune parameters for, let's say, a gradient boosting machine, for example. How many trees to train? What kind of learning rate to apply? What kind of regularization to apply? So that actually brought us to the second iteration, which was H2O open source AutoML. So now you're not just actually able to train the model, you're also able to put your data in, ask the algorithm to build the model for you, and it will actually do not just the model building, it also find the best hyperparameters settings for you as well. So, and not just that, actually, it's also able to ensemble different models together to get even better results. So at the process of building H2O open source, that was actually right in the middle of Python revolution in machine learning. So a lot of libraries was available on Python, and Python was actually quite fast, actually getting attention and getting the recognition as one of the key choice as a language for machine learning and data science. So also Java had some sort of the software limitation from our perspective. It wasn't allow us to iterate fairly quickly, so we decided to build our next product based on a Python, which enables us basically using all available open source library and iterates fairly quickly enough to get things done. That's how Driverless AI been born. Also, there is one more quite important thing that actually remain almost untouched by H2O open source, and I'm talking about feature engineering. So H2O open source does have some feature engineering capabilities, but it's not a feature engineering per se, it's more like a feature representation. So it's able to present your feature, let's say categorical feature in a one hot encoding format. But it's not allowing, it doesn't search the best feature representation automatically for you, which Driverless AI does. So after we built Driverless AI, we opened the door basically to a new family of new products like Hydrogen Torch you saw previously, and Document AI. So what's capability of Driverless AI? and in terms of AutoML. So well, first of all, we try to bake experience of Kaggle Grandmasters into the product, like some common pitfall to avoid, the best approach, the best overall approach for handling the data, handling the missing values in the data, the best presets of the hyperparameter criteria to start from, because we still have a cold start problem and we need to find the best hyperparameters as fast as possible. So we have a presets of the best hyperparameters for XGBoost, LightGBM inside the product, which actually allows you to build a fairly good models immediately after the start, and them slowly getting them better and better. It's fast and scalable, which is, yeah, definitely we're trying to, and I've been pushed constantly by the CTO of a company to build, not just like a very reliable approach in Driverless AI, but also fast enough to be, useful by the business, because the less time you spend building model, the more time you actually can spend, thinking about what kind of data to put into the model, into the product, into the tool, and about business problems you can actually solve using it. So it's Driverless AI also multi-model, so it actually can handle image data, textual information for you, which is sometimes can be quite handy. One of the biggest factors actually of Driverless AI, it's fairly easy to deploy into production. So at the end of as a result of your experiments, actually, as a result of the Driverless AI run, you can actually have a deployable wheel package, Python wheel package if you choose, or maybe it's going to be deployable Java object, which is fairly easy to use. Also, the pipeline basically you can actually deploy can be quite complex, but there's complexity actually hidden from you. So it actually can, inside this package, inside this module, inside this Java object, for example, it can be full feature transformations needed for a model to run, and the model itself. So it's a completely ready to use. You don't need anything actually from it except this package to run it. So how usually the standard process of Driverless AI run looks like? So, and common usage pattern, basically you upload the data, you check the data, you click I want to predict the data, and you go basically on a second screen, you identify the target, you might identify a test, maybe a validation set you have, you hit the run, you launch the experiment, and basically you're done, right? So the remaining thing you can actually also do, you have to check a warning log to check if there's any notifications or warning for you. But let's say even if Driverless AI identifies something suspicious in your data, right? The only way you can actually react on that, you have to stop the experiment, check your data, change something in your data, maybe change something in the Driverless AI settings, and start from scratch. So it actually, that means you still require some data science skills, right? And some knowledge about the data set you have before you run. So that kind of implies that Driverless AI still expects more or less clean data from you. Also, some default parameters might be not applicable in your particular case. Like, for example, by default, Driverless AI might actually think you need actually a Java deployable object as a result of the experimentation. That also limits the capability of Driverless in some sense. For example, we don't have a BERT model in Java yet. We're working on that, but it's still not in Java. So you have to have a Python package to be able to run the scoring package, right, in that case. But if you select the module, if you select the Java, that means you won't be able, the BERT model is going to be disabled by default, right? And that's something you have to know. You can learn it from the documentation, but it's kind of strange that the model doesn't tell us to, beforehand. So basically what I'm trying to explain here is some sort of the lack of interactivity in the model, right? You have to think beforehand about what you can do and what you cannot, what you'd like to get from the Driverless AI. And Driverless AI being quite, you can actually set up a lot of things inside. It's quite flexible in terms of what you can do and how you can actually design your experiment. It's also quite demanding to, you have to know beforehand a lot of stuff. So that's why we decided to start building a different wizards in Driverless AI. And that's the moment Nitro came into play. So Nitra is a low-code solution. It's open source, built by our team. It's basically started from the wave, and then Nitra been released. And the whole idea, whole promise of Nitra, it's you can build rich web applications in Python. So all you have to do, you just need to learn Python. You don't have to learn anything else than just a Python. And in Python, building a Python code, you can build a quite rich application in a matter of minutes. So we are going to use this tool inside Driverless AI as well. So basically, we're trying to use our own libraries, because that's going to be that's definitely a good idea to do. And Nitra actually going to be used to build wizards inside the Driverless AI, which actually help us to iterate fairly quickly and build a lot of different wizards, not without any limitation, basically. So, for example, these kind of wizards will allow us to do interactive experiment, add interactivity into Driverless AI. So before you're actually able to run an experiment, you can actually click the wizard, and it actually will guide you through a series of questions and series of checks on your data. For example, it's going to check the data on a leakage. And by leakage here, we mean, features which are suspiciously good in predicting the target, and Driverless AI can immediately identify that and say like, hey, you know what? Using this feature, we can have a UEC of 0.99 basically, right? That's great, but maybe it's too high actually. So it might be, something wrong with this feature. Would you like to remove this feature from the data set? And that's, it asks the user for input. Also, as I mentioned before, it can guide you for expert settings. So let's say if it can ask you, do you actually need the production and let's say Java object into your production code? Are you actually running the model to put it into production, and all other stuff? Like, for example, at the end, I'll also show you a Python code, how to, let's say, run this experimentation with these particular settings from the Python, not from the user interface. So in the future, there's going to be a first wizard wizard that actually guide you through setting up the experiment to build a prediction model. In next release, there's going to be various of different wizards available. Like you can actually join the data sets inside Driverless AI without leaving the driverless at all. You can have a business calculation of a different business impact inside the Driverless AI as well. So, but basically for the last 3 or so months, most of the changes actually been done under the hood. So we spend a lot of time building a new baseline for Driverless AI and starting constantly checking Driverless AI performance against this baseline and against our AutoML tool on this baseline. So what good about this baseline? It's still I specifically made this table unreadable, very, very small. So because baseline is still under construction, so we're still building and identifying the data sets we can add. For example, right now we have only 40 plus data set for classification. That means we do need an additional data set for baseline on regression problems. But it was a great data set because we started and Driverless AI performed really, really bad on this baseline. We've been the best on one data set out against 40, and we were the worst in 17 data sets, like a 50% of the baseline data sets compared to the rest open sourced AutoML tools. That was a cold shower in some sense, right? So we spent the next 3 months optimizing Driverless AI in a different ways, make it more stable, robust to different noise in the data. So at this very moment, our tool basically is producing the best results on 23 of the data sets and from this baseline, and just being worse on just one data set out of 40 compared to the rest of open source libraries. So yeah, that's basically all I have for you for today. Thank you for listening to me, and I'm ready to take questions. Yeah, I specifically made it a very short presentation, so give you more time actually, before the next one. So no questions, right? That's wonderful. Okay, in that case, thank you.